In this lesson, I will show visually the differences between the arithmetic and geometric mean. I will apply it to stock valuation, and finally I'll show where both are used in finance. So I'm going to start with trying to visualize your geometric mean by using the means extreme product property. Now if you take a look here on your screen, you're going to see a formula here, or I won't say a formula, you're going to see a 1 equals over some number equals some number over 4. And the question would be, what number does this have to be to make this equal? Now, it sounds like algebra. It is algebra, because algebra is the great equalizer. And you could sit here and look at this for just a minute, and you'd probably guess that 2 would be the right answer. And you'd be correct, because 1 over 2 is half, and 2 over 4 is a half. Now, if we look at that number 2 would be your geometric mean. Now, if I want to do the arithmetic mean would be 1 plus 4 equals 2.5. So we see the arithmetic mean here is greater than the geometric mean. Now let's do it again with a different number, and let's do a little algebra here. Let's use a number such as let's put 2 over an x equals an x over an 18. Now can you think about that one? It may take you a minute. We couldn't just do some basic algebra here, cross multiply and get x squared equals 36, and then we take the square root of both, and this just becomes x, and this becomes 6. So now I have, again, the geometric mean, which is 6. Now if I do the arithmetic mean here, which was 2 plus the 18, I get 20, and 20 divided by 2 gives me 10, whereas this one was 5, and 5 divided by 2 is 2.5%, is 2.5. So let's go ahead and let's kind of look at it from a stock valuation. From a stock standpoint, let me go ahead and draw a picture here. Let's draw a line here. And let's put a 0 here, because we know a stock cannot be less than 0. So let's go ahead and do a normal. Well, it's not normal, because if you take a look at it, it's skewed this way. It's skewed. Now basically what happens is that your geometric mean is more of the median. So we can call this the geo mean, which is more like the median here, whereas your arithmetic mean tends to, the mean here, which is your normal mean, tends to follow the tail. So it's going to be a little larger, and you see here it's always a little larger. Now the reason it does this is because basically your returns are normal distributed, whereas your price levels are generally log normal distributed. Or another way of looking at it is, as we increase the volatility then erodes, for lack of a better word, our returns, lowers our returns, or what we find is the geometric mean is at half the variance. Now let's go ahead and do some calculations really quick. So we kind of visualize it here, and we see why, because the arithmetic mean is more of the mean here, and since this is skewed this direction, it's going to follow the tail, and the geometric mean is going to be more like the median. So let's go ahead and take a look at it here. We take a look. I've calculated the arithmetic and the geometric mean for years of return. So I got year 1 through 5. You can see 10, 25, 12, negative, loss, 2 and 12. And I calculated both of them using an Excel function and by hand. So here's the Excel function. The Excel function is equals average of these numbers. Now what did equals average do? Well, equals average did this right here. And if you take a look at it, all this did was it took each of them, the 0.1, the 0.25, the negative 12, 0.02, and the 12.12, 12%, added them all up and divided by the number of periods here, which was 5 periods. And you can see I did it both using Excel and longhand. Now I'm going to go ahead and look at the geometric mean. Now remember, geometric mean is going to be a little less than that, and it was. It's 6.69. And let's take a look at it longhand first, and then we'll go ahead and look at it how Excel will calculate it. Longhand is basically one of two ways. One way, let me get a pen here. One way is that I take the product of each of these. So to start, it'd be the square root, and of course there's 5, so I got to put a 5 here. And then it would be the product of each one of these. So I take the 1 plus 10%, and I'd multiply it by the 1 plus the 25%, so on and so forth, all the way to the end. And then once I get the answer, I have to subtract a 1 from it to get back to the number here. So let's go back and look at the formula. Here's the formula longhand. So here's the 1, each one of them. Of course, the negative 12 would be less than 1.88. I subtracted just 12 from the 1. And did a little different here. Instead of doing the square root to the 5th, I just raised it to the 1/5 power and subtracted the 1. And I did it longhand. However, Excel will allow me to do it as well. It's just the geomean. Now, in order to do the geomean, I had to first get an array. So I had to do the equal sum product to get an array. Here's the array. To get the geomean, let's go back to it. There we go. Geomean is the 3 through the 7. I added my 1 like I did, but I did it all at once, and I subtracted my 1. So if you want to pause it and write that, you're more than welcome to write that equation down. Now let's finally apply it to a stock price and then look at where it's important in finance. I have a stock price of $50, a volatility of 20%, expected return of 10%. Now I want to know the future stock price in 5 years using the arithmetic or the mean, as we talked about earlier, this mean versus the geometric median. Well, the arithmetic mean is simply this, and I took the stock price, and you can see it up in the functions key, exponential function, which is just the natural log, because I'm going to do continuous compounding, and I multiplied that by the expected return times the number of years. And you can see over here. And I got $82. So if you want to pause and write that equation down, you're more than welcome to do that. Now, let's look at the geometric mean. As you see, the geometric mean a little different. I used 8%. How do I get the 8% to get the stock price? Well, the geometric mean is basically the G5 here is the expected return minus the volatility raised, or half the volatility. So I raised it to the 1/2, the 2 divided by 2 to get half here. If you take a look at it, that's the equation. And when I did this formula here, it gave me the geomean. So now I just applied the geomean to the stock price here. So I took the stock price, I multiplied by the exponential function, and then I multiplied it by the expected return and half the variance times the time. And I got this answer here. Now, just to kind of pull down here, I went ahead and just for the fun of it showed you why geometric means are more important. Well, I took the 8% and I compounded it just to get close to continuous. I did it 360 daily. So I got the effective rate compounded daily, which is a little bit less than continuous. However, if you take a look, I then just found the future value of daily compounding over 5 years at the 50% price, just using the basic function of Excel, future value and present value, future value, and I got the exact same price. You can see there's very little difference between continuous versus daily. This is why geometric is so important, because it is the actual true return that an investor would receive. However, we do use the arithmetic means. We use the arithmetic means for multi-factor models and capital asset pricing model, since they are both single period models. So we will use the arithmetic model, whereas we use the geometric model as a true return. So in summary, we do use the arithmetic models in single model returns like CAPM and multi-factor, whereas the geometric is the actual true return.